Hey everybody, in this video we are looking at Chapter 1, Section 7, and the name of Section 7 is Inequalities. So we should have all have seen inequalities before. In Algebra 1, we have the less than, greater than symbols, less than or equal to, greater than or equal to. I feel like a lot of people stumble over their words, and I constantly hear less than or greater than, which that's weird, right? If it's less than or greater than 4, then it's everything except 4, right? Like it's kind of, let's think before we speak, shall we? But we're going to start off with linear inequalities, which are inequalities in one variable. Now, they might be linear in the sense that it's x to the first power, and that's all we're really working with. But you don't see the y equals part of it. That makes it a linear equation to graph. However, I am going to do some modeling of this on Desmos for you to kind of show you how this works, because when we get into quadratic and other higher degree polynomial inequalities, if you have the ability to have the visual of it in your head, I think it'll help you out a lot in being super quick with like a super visual, efficient, amazing method to do it instead of testing intervals, which I think is silly. But anyhow, here we have a classic linear inequality, and this is asking us when, right? When is the linear equation, this guy, right? No, that's too thick. Let's make it. When is this linear equation, negative 3x plus 5, when is that going to be greater than, above, higher than the value of negative 7? Because of the way graphs behave, okay? A linear equation with a negative slope is going to look like a line going down from left to right when you graph it on a plane. And then y equals negative 7, if these were both y equals, will be a horizontal line at negative 7. And if I'm asking when is the red graph, right? When is the red graph greater than or above the blue graph? My answer is going to be something like negative infinity, comma, whatever that number is, some number with a parenthesis. Okay, that's what your answer should look like. It's always above the blue from negative infinity until they finally inevitably intersect, because they will intersect. So that's what's happening here. And in order to solve it, we just use algebra. No one's asking you to reinvent the wheel or to do this with with your mind, okay? So what we want to do is isolate the variable. It's that simple when it's a linear inequality. So I'm going to subtract 5 from both sides. That leaves me with negative 3x is going to still be greater than, if I subtract 5 from negative 7, I get negative 12 right there. Then I'm going to divide both sides by negative 3. Hopefully we all remember negative means opposite. Opposite indicates that we're going to have to do some changing of things. So when you divide by a negative or multiply both sides by a negative in an inequality, your inequality sign is going to flip only when you multiply or divide both sides by a negative value. Then negative 12 divided by negative 3 is positive 4. Now your answer is, final answer, when x is less than 4. So using interval notation, which is, more appropriate, using interval notation to write our answer, it's going to be, now maybe you could just visualize x is less than 4 will be negative infinity, comma, 4 with a parenthesis. Not everybody is visual like that. Some people may need a little bit more practice at that. So in the meantime, if you are not quite there, I would do a little sketch-a-rooney. Here's 4, just visualizing it on a number line. What does that mean? X is less than 4, so that's to the left. X is less than 4, and less than is not including. So I'm going to have an open circle. We say it's open when it's not colored in. An open circle there at the negative 4, or I'm sorry, positive 4. And that's going to help you then maybe write your interval notation, negative infinity, because you're starting over here, going, going, going until the 4, and we don't include it. So then we get the interval notation that I wrote right there for our final answer, right? So there you have your final answer. Now, I did tell you I was going to show you a visual. So let's pop over. Here is Desmos. So I already went into Desmos. I already graphed these two equations, okay? Now, in these two equations, I have them turned off at the moment just so, oh no, not, I don't have them turned off. Duh, they're on. You see them. Hello. So we see our two equations right here. Now, where do they intersect? They intersect when x is 4, right? And y is -7. But when we're solving, is y even involved? No, right? We're kind of doing almost substitution in a sense because we filled -7 in for the y, and then we position the equation to say, or inequality to say, okay, when is red above blue, right? So the red is above the blue, all this area, right? Red is above the blue, coming from the left, coming, always above until here they're level, and then here red is below, okay? So when is red above, greater than blue? I do want to put in here, let me do, I want to put in a vertical line just to kind of model for you guys, x equals h, um, but I want, ooh, can I not do x equals, and put a slider in here? Um, I don't, what is this doing? I don't, mm, can I not do a vertical line? I thought I could. Why do I feel like I've, um, okay. But I don't want that. I guess I'll do Y. Okay. Mm, not that it matters if it's K or H, not that any of this matters, but I'm being fussy and I'm going to, okay. So this is the region I'm looking at when the red is above the blue, right? It's not doing what I want it to do. I really wanted X. Anyhow, so I really want along this line, blue is under, blue is under, blue is under until here, and then it's not, right? Now, because we have a linear equation, sorry, I really thought I was able to show you something. I did it with my class the other day, one of my pre-calc classes, and I don't know, I can't get it to work on here right now. I forget how I did it. But when you have a linear equation is, well, a line, it's straight. So it's never going to come around, right? Bend and cross back through my value anywhere else, right? That's what makes linear inequalities so easy, okay? So we're really saying that the answer to this is when x is less than 4. Let me even just type that in. X is less than 4. I mean, it's there. That is sort of what I wanted. So that is my solution, right? And that's what we wrote down using interval notation. We described that region from left till right, okay? Anyhow, we will see, I'll pull up Desmos again in some other examples, but I do think it's important for you to kind of see that. Another thing we can do, actually, should I go back over here? Yeah, let me see one more time. If I go back over here, right? Let's just get rid of some of this. Okay, so when I did one step, right, we subtracted 5 from both sides. Okay, so I'm going to shut these off. Actually, I could leave them on, but if once I did that, this side became just -3x, and this became -12. And let's turn them back on. Now, if we look again, do you see, even though these are different equations, they're not the same equations, they are moved, but it's still true at that same place. They're still true when x is less than 4. So if you're ever solving something and you were like, oh, I don't know if I'm doing this right, your solution shouldn't change as you go, right? So again, this was negative 3x plus 5, and this was negative 7, right? So that's where everything was. I got rid of this. I got this to become this, and it's still the same answer. Then we divided both sides by negative 3. So this one became just x, and then this one became positive 4. Oops, positive 4. And you see, that's why my sign has to flip, because now my line that was decreasing is now an increasing line. So now I want to know when is it under in order to have that same answer. So that's why I went from greater than to less than. Okay, so this is just all a visual journey through us solving the inequality. Okay, so if you stayed till the end, great, I'm happy for you. That's the end of this video. We will see a different example over here. I will model it with Desmos as well if you're curious at the end. But that's it for now. Check the playlist. Thumbs up if you're a genius. Thumbs down if you are sad about inequalities. And that's it. Adios.